Check. Yes. What's up, everybody? This is me, Yawar Manzoor, and I believe everybody of you is doing great and nice. Come on, I just need to know in the live chat if I'm live right now. Yes, we are actually live. Okay. Okay, that's fine. Good evening. Okay. So I just need to know, is everybody fine? Is everybody doing great? Is everybody all right? What's happening with your life? I just need to know in the live chat. Come on, everybody. Let's just basically focus on this one today. So today we're going to be talking about the acceleration time graph, what this acceleration time graph is all about. Okay. Once we get done with that, afterwards, we'll move on to something else. Also, I'll be showing you the IIT JEE problems once we get done with this one. Today, we'll take the feel of acceleration time graph. What is the meaning of acceleration time graph? In the previous two lectures, we have studied the velocity time graph, position time graph, what that is all about. Understand? Now, in the today's lecture, we're going to be talking about the acceleration time graph. Where does it come from? Why do we study this? What is the actual meaning of this acceleration time graph? And some of the previous year IIT JEE problems I'll be showing you at the end as well. Okay? Yeah, hi. So let the people join, then we will start accordingly. And my name is Yawar Manzoor, and this is a piece of information about me. You can just read it out from the screen itself. Fine. Let's move. Now, apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Okay. There, country's top educators are teaching you. Country's top educators are over there. Understand? They provide you the good level content. Understand? Now, if you take this plus subscription, you can basically take the subscriptions over there. If you take this plus subscription, in this plus subscription, there are some benefits that you're gonna get. The first one is live classes. The second one is weekly tests. You will get the structured courses. You will get the unlimited access. Means you can watch anybody's lecture in that particular category. In that particular category, you can watch anybody's lecture. Fine. Now, apart from this, you can take basically this Iconic subscription as well. In this Iconic subscription, you will be getting the personal guidance, you will be getting test analysis, you will be getting experts guidelines, you will be getting study materials, study planners. So these are all the benefits you get in Iconic. And apart from this, you will be getting all the benefits you get in Plus. You will be getting all of those in Iconic subscription as well. That's why we call this Iconic subscription as golden subscription. Fine. Now, so this is my username on Unacademy. You can definitely follow me over there. Understand? My name is Yawar Manzoor and this is my username on Unacademy. Follow me. If you have any sort of doubt, you can ask me over there itself and I'll definitely help you in that. Now, people keep asking every single time, sir, there are no batches in Unacademy which are completely in English language. So Unacademy has recently launched the batches which are completely in English language. So this Spark batch is for JEE Mains and Advanced 2023 people. So definitely you can join this batch if you want to boost your rank in your upcoming JEE, because the top educators from different states are in these branches. So they will basically make you understand everything. Yeah. Okay. Thank you. My explanation is superb. Come on. Where are the people exactly today? Okay. Fine. Now, this is another batch that we have launched recently on Unacademy. This is for 12th class people or the people who are appearing for JEE Advanced 2022. Understand? Mains and Advanced. They can definitely enroll in this Shine batch in which these top educators from different states are teaching you over there. So this has already started from 11th of August. Okay. You can still join this batch and boost your rank in your upcoming JEE. I need to know in the live chat what's going on. How are you feeling? Do let me know. Is everything fine? And you can take this IIT JEE Iconic subscription as well on Unacademy. So what is this Iconic subscription? What are the benefits? Some extra benefits you're gonna get in this one. If you take it for 12 months, 18 months and 24 months, you will get the branded notes that will be delivered to your doorstep. Those branded notes will be completely in hard copy. Okay, no need to basically read from the PDF from now onwards. And if you take this plus subscription offer, if you take it for 12 months and 24 months, you'll be getting 2 months of extension. This is for free, understand? And now is the most important point. This plus subscription you can take it definitely for 3 months, you can take it for 6 months, 12 months, 18 months and 24 months. Okay, for 3 months it will be somewhere around 17,500, and if you use my code, this Yawar, you can definitely get the maximum possible discount, understand? So this is for 34650 over there. And if you use my code on your 3 months course for plus, you will be getting it for 15,000 only. Okay, normal price is 17,500. You can take this for 12 months as well, 18 months and 24 months. The prices are listed over here. Want the maximum possible discount? Use this code. Okay, fine. Yes sir, fine. You are giving away that how we should manage ourselves for JEE. Yeah, exactly. Every single time I keep giving you the strategies. I keep posting the strategy videos on that one. A being artist, what's going on, man? Okay, now you can take this iconic subscription as well. You can take it for 12 months, you can take it for 18 months and 24 months as well. Now, if you take it for 12 months, this is the price. This is the price for 18 months and this is price for 24 months. If you want the maximum possible discount, this is the code you can definitely use. This code you can definitely use for the maximum possible discount in all of these courses. Fine. And this is the IIT JEE Mega Combat. You can win up to 4 crore rupees scholarship in this one if you give it on 22nd at 11 AM exactly. There will be 60 questions and there will be 60 minutes. You will have to answer the 21 questions, and these are the benefits you're gonna get if you get the ranks accordingly, understand? And in order to enroll in this one, you can use my code, that is YAWAR, understand? Yawar. Okay, fine. Previously somebody asked me, sir, what is the meaning of this Yawar? Okay, so Unacademy is IIT JEE Mega Combat. This is on 22nd. I want you people to join this one in order to get this scholarship. That's very heavy scholarship. Now, if you find any of my content as inappropriate, you can definitely report. The link will be in the description below. Fine. Now, let's get started. Let's talk about this acceleration time graph. What this acceleration time graph is all about. Understand? Let's focus on this acceleration time graph. Previously, I was talking about the velocity time graph. Previously, I was talking about the position time graph. Understand? We're done with all of the questions from both of those topics. Now, today we will be talking about this acceleration time graph. What is acceleration time graph? As I explained previously also, if acceleration is given over here, time is given, for example, this car is moving, understand? Its acceleration is, for example, changing in this case. This is just an example, okay? Its acceleration is changing. Its time is changing, understand? So this acceleration is changing with time. So I'm asking you to plot the acceleration time graph of this situation. Understand? You have to basically represent this graphically. That is nothing but acceleration time graph of this one. That's all. Understand? This is how we actually do it. I have told you this previously also. So what is the acceleration time graph of this one? We can definitely draw it. That means this is the example. This is the case that we are given over here. We have to plot the same situation graphically. That will be the graph of this. That will be the acceleration time graph of this example, this scenario. It is very simple. Now, how do we exactly do that? We can basically make it like this. We can basically make it like this. If we say this is acceleration on this axis, this is time over here. Now, I'm saying that when time is 1 second, at that time, acceleration is 1 meter per second square. Meter per second square. Over here, it is 2 meter per second square. When time is 2 seconds, 1 second, 3 seconds, 4 seconds. It is 3 meter per second square. 4 meter per second square. I have made you understand this also. What is this meter per second square? It's meter per second per second. Okay. Now, when time was 1 second, acceleration is 1 meter per second square. Okay. So I can definitely make it over here. Okay. This is the first point. When basically time is 1 second, over here time is 1. Acceleration is what? Acceleration is 1 meter per second square. Understand? So when basically time is 2, acceleration is 2. I can definitely make it over here. So this will be 2. This will be the third point and this will be the fourth point. When time is 3 seconds, acceleration is this? Yes. Yeah, exactly. Fine. So now I want you people to basically join this one. So it'll be something like this. Understand? A straight line. Understand? Add some inclination. So this is the acceleration time graph of this example. That's all. Understand? So from now onwards, they will ask us, the questionnaire will basically ask us, he will give us a situation. The acceleration of a body is changing like this. Time is this. He will ask us to plot its acceleration time graph. Then we will plot the acceleration time graph of that situation. So right now I'm plotting the acceleration time graph of this situation, of this data. Over there, we'll have to plot the acceleration time graph of different situations that will be given in the upcoming time. Fine. I hope everybody is understanding this one. Once we get done with this, a bit of its theoretical part, this is not the, this is also the practical one, or this one. I'll show you the problems at the end, which are asked in previous year IIT JEEs, okay? Now, everybody understood till here? Drop a thumbs up if you guys understood this properly. Everybody, send me and like this lecture as soon as possible. Fine. Now see, we say slope of acceleration time graph. What is slope of acceleration time graph? Huh? Now, previously, you said slope of position time graph, that gives us velocity. Slope of velocity time graph, that gives us acceleration. Now the point over here is, what is slope of acceleration time graph? Can anybody tell me in the live chat, what is slope of acceleration time graph? What is the quantity that we can get from this slope of acceleration time graph? If I say, for example, the graph is something like this, what will be the slope of this acceleration time graph? You know how to basically find the slope. In previous lectures, we have basically, I have explained this properly. Now, can I say in this case, slope is nothing but, that is what? Tan of theta. Hey, what is slope? Slope is nothing but steepness. This is having zero slope. Now, if we keep on increasing this inclination, if we keep on increasing this steepness, means slope is increasing. This is having more slope. This is having infinite slope. This is having zero slope. Understand? Yes. So, can we say that is nothing but slope of this tan theta? I'm asking you to find the slope between this point and this point. Understand, like we did in the previous classes. Slope between this point and this point. Can you tell me what is the slope between these 2 points? You will say, sir, it is nothing but perpendicular upon base. Understand? So slope is nothing but, it is what? It is perpendicular upon base. We can clearly say it like that. Everybody is understanding? Yes. Hi, Vidya. Hi. Hey, what are you saying, Praveen? dv by dt. Talking about acceleration time graph, okay? Fine. So this will be nothing but, in this case, can we say what is the perpendicular? So this much is basically the perpendicular. So how much? Over here, can I say the value of this acceleration? On this axis, we say when you are basically traveling along this line, if I say, for example, means you are traveling in time as well as in acceleration, means you are traveling in x as well as in y. So over here, can I say acceleration is a1 or 0? Over here, when the point is at this point, acceleration is what? That's a2 or something like, or we say 0 to a1 to a2. And at this point, can we say time is basically t1? At this point, time is basically t2. When you reach here, time is basically t2. So can we say in this case, how much is perpendicular? This distance is how much? A2 minus A1, final point minus initial point. How much is this one? You will say that is T2 minus T1. Can we put it over here? Perpendicular upon base, because tan theta is nothing but perpendicular upon base if this is making theta with this one. Okay. So I can definitely write it over here. That is nothing but A2 minus A1 upon T2 minus T1. Understand? Now, can I write this as a delta A? What is A2 minus A1? Change in A. So I'm just writing that is delta A. What is T2 minus T1? That is nothing but a delta T. Fine. Everybody understood what I am trying to say basically. Now, let me just give you the feel. See, previously, we said dv by dt or delta v by delta t is nothing but average acceleration. Delta s by delta t is nothing but average velocity. Now, point over here is, what is this delta a by delta t? Rate of change of acceleration with time. This quantity is nothing but this delta a by delta t. We call it nothing but jerk. Understand? This is the new quantity that I have introduced over here. Okay, everybody, if you are liking this one, come on, I need to know in the live chat. So this is delta I by delta t. With what rate acceleration is changing with time? Understand? Rate of change of acceleration with time, that's what we call the jerk. This is not in your syllabus still, I'm saying, okay? This is what we call the jerk. Now, this is average rate of change, delta A by delta t. This is nothing but average rate of change of acceleration with time. So can we call this as, this is average jerk? 100% we can call this as average jerk, okay? Everybody, I'll just give you the simple example over here. For example, if I say this is the acceleration, this is a time over here, and the graph is, for example, coming out to be like this. Acceleration is 10 meter per second square. At over here, time is basically what? 10 seconds. If I ask you what is the slope from this point to this point, you will say simply that is tan of theta. So what will you exactly say? You will say that is nothing but delta A by delta t. What is that? That is nothing but 10 minus 0, 10 minus 0 upon this 10 minus 0. It will be nothing but 1. That is 1 what? 1. 1 will be jerk. What? 1 exactly. What will be the unit? At the time of when we were talking about acceleration, that is 1 meter per second square. Understand? In case of this, what is this? This is acceleration upon time. This is acceleration. For acceleration, what is unit? That is meter per second square. And for time, what is that? Is second. So how much it will be? It will be meter per second square, meter per second cube exactly. Can we say it like that? 100%. So it will be nothing but meter per second cube. And this is what we call the jerk. Understand? So in this case, in which acceleration is, a car is basically traveling. A car is traveling. Acceleration is changing like this. This is the graph of that acceleration. Understand? So we are asking you, I'm asking you to find the rate of change of acceleration. You got the rate of change of acceleration in this example. That is 1. 1 what? This came out to be, this is what we call the jerk. 1 meter per second cube. Understand? Like we were talking about meter per second. Like what is, if I say 4 meter per second is velocity. Every second you are traveling covering the 4 meters. If I say 4 meter per second square is acceleration, means every second you are changing the velocity by 4 meter per second, because this is nothing but meter per second per second. Now if I ask you 4 meter per second cube, means every second it is nothing but, this is 4 meter per second. Let me just show you over here. It is nothing but 4 meter per second square upon second. So this is nothing but every second you are changing the acceleration by 4 meter per second square. Everybody is understanding this one? Drop a thumbs up. Otherwise, I'll explain this once again. Okay, this is definitely not in your syllabus. Still, I am giving you this beautiful information because you will love it definitely. The physics lovers will definitely love it. What this jerk is all about. Okay. Come on. Got the jerk, sir. Sir, please tell once again. Hey, what am I supposed to tell once again? What exactly? This jerk that I explained. I'll explain this once again after some time. Don't worry about that. I'll have to tell you lots and lots of extra information today. Okay? Don't worry about that. So can we say this is nothing but jerk? This is nothing but jerk, that is delta A by delta T. Understand? Fine. Now, if I ask you to tell me the slope at a point, let's move on to the next slide. If I ask you to tell me the slope at a point in case of acceleration time graph, fine. See, this is nothing but acceleration time graph. This shouldn't be over here velocity time graph. This is acceleration time graph. Okay, fine. I'll just make the curve over here. Now, if I ask you to tell me the slope in this case, in this beautiful case, between this point and this point, if I ask you to tell me the slope, simply you will use the same concept that I told you previously. That is how much? That is A2 by A1. This has to be over here A. This has to be over here A. This has to be over here A. Okay, fine. Now, between any 2 points, in case of straight line, slope is same. Understand? Between any 2 points. At every point, slope is same. Because why? Because at this point also theta will be same. At this point also theta will be same. So slope is nothing but, we say slope is nothing but, that is a tan of theta. Understand? Fine. Now, in case of a curve, slope keeps on changing. Now, if I ask you to tell me the slope between this point and this point, you can easily use the previous concept. Take this point, delta S by delta A by delta T. That is very simple. Okay. Yes, physics is love. Now, if I ask you to tell me the slope at a point, how you are supposed to exactly do that? By using the method of differentiation that I have told you 100 times, explained in very detail in the previous lectures. If you have any sort of confusion, you can watch those lectures also. And everybody like this lecture as soon as possible. So at any point, if you are supposed to find the slope, you draw a tangent. Understand? You check how much theta it is making with the x-axis or the time axis in this case. Then you check at this point, slope will be nothing but, see, I'm not gonna tell you this in detail once again, how this tangent is formed over here, how this slope will be exactly over here, how the slope is changing. So this I have explained previously. Understand? So can I say in this case is slope is nothing but tan of theta. In case of tangent touching this curve at a single point, so in that case we say delta a by delta t will be very small, that is a dA by dt. So can we say that that is nothing but dA by dt? So this dA by dt is nothing but, this is what we call the instantaneous jerk. This is nothing but dA by dt. Okay, a lot of people you will find they will say this, the meaning of rate of change of acceleration with time or slope of acceleration time graph gives you nothing. No, it gives you actually jerk. Okay, fine. This is what we call the second derivative of position. Understand? I'll tell you that also. Now comes the piece of gold. Everybody of you, I want to listen to me very, very, very carefully. Okay, because I'll be sharing you the piece of gold, this information that you will probably love. This you will love. Everybody listen to me very carefully. This is not completely not in your syllabus. Okay, now see, we say basically, we say if we have displacement, if we differentiate this displacement, we find the rate of change of displacement. So that is nothing but ds by dt. What we will get? We get velocity. Then again, if we differentiate this one, if we find the rate of change of velocity, that is a dv by dt. What we get? We get acceleration. Then again, if we differentiate this acceleration, rate of change of acceleration, that is a dA by dt, we get, that is nothing but jerk. Understand? Now, when we basically differentiate, wonder certain, this is the piece of gold. You will definitely love it, everybody. Now, if we differentiate this jerk, that is a dJ by dt. What we gonna get exactly? That is nothing but, this is what we call the snap. Okay, fine. We represent it with S or something else. This is not a concept. I'm saying you, this is a piece of gold, means this is a very useful information. Understand? This is something out of the box. That means, okay. Okay, Praveen, don't get confused. This is not a concept. Fine. So then if we differentiate this one, we find the rate of change of snap. With what rate this snap is changing with time, we can say basically that is a ds by dt. This is not this displacement. Understand? I'll just change over here. I'll just write it as dx. Understand? X, displacement. We represent displacement with x also, not a problem. So it will give us nothing but, that is what we call the crackle. Afterwards, understand? Everybody is loving this one. Everybody is loving this one. I hope, yes. And when we differentiate this crackle, dc by dt, we get what? That's what we call the pop. Understand? These are all the derivatives. These are all the derivatives. Understand? Understand, everybody? These are all the rate of change. That's why I told you previously, rate of change is a golden concept. Okay, this is a golden concept. Keep this thing in your mind. These are all the rate of changes. Understand? Now let's talk about some of the rate of change over here. If I say, for example, let's talk about this snap. If I talk about this snap over here, let me just mark it. Okay, if I say, for example, this snap, everybody listen to me very carefully. Everybody is loving this one. Come on. So I'm fine. You say, Ankit, Madhav. So if I say, for example, this snap, okay, this snap, can we say it nothing but
dj by dt 100%. Can we say it nothing but that is dA square by dt? Understand? Second derivative of what? Acceleration. Can we say it like that? So finally, can we say it like this snap is nothing but dv cube by dt? Yes, exactly. Finally, can we say it nothing but dx 4 by dt 4 square. Understand? Everybody, what is this? So we call this snap as that is fourth derivative of position. So this is basically fourth derivative of position. What does that exactly mean? That means if you take position over here, if you differentiate it once, you will get velocity. If you again differentiate it, means if you differentiate it twice, you will get acceleration. If you differentiate it thrice, you will get this jerk. If you differentiate it 4 times, you will get this snap. That's why I told you this snap is in reverse process. We can say this snap is nothing but fourth derivative of position. Everybody loving this one, man. Okay. Now similarly, we can talk about this axle. We can talk about this jerk also. Can we write this jerk? That is nothing but dA by dt. Exactly. Fine. Can we write this? This is nothing but dv square by dt square. Can we write this jerk? That is nothing but dx cube by dt cube. So this jerk is nothing but third derivative of position. Means if we differentiate this position thrice, we will get what? That's what we call the jerk. Everybody.
Your teaching stuff. Thanks, man. Means a lot, man.
Similarly, from now onwards, if I ask you what is this crackle, you will say this is nothing but fifth derivative of position. Understand? Similarly, if we talk about the snap once again, this is the third derivative of velocity. If you differentiate this velocity twice, you will get what? You will get nothing but snap. Okay, this is a piece of information. Accordingly, you can make for everything. Accordingly, you can make for every quantity over here, like I told you this one. Now, let's move on to the next one. Area under the acceleration time graph. What is area under the acceleration time graph? It gives us, does it give us velocity or change in velocity? Let's talk about that only. Now, see, if I say, for example, this car is traveling, it travels from this point to this point. Okay.
A second. Okay.
Now see, if I say, for example, this car travels from this point to this point, understand? Now, afterwards, if I say this car is traveling from, it's having the constant acceleration. Traveling with a constant acceleration means velocity is not changing. Acceleration is constant. Sorry, velocity is changing, but uniformly. Understand? That's why acceleration is constant. Acceleration is not changing. Understand? So acceleration over here is basically constant. Acceleration is constant. Now, if I say from this point to this point, it takes t is equal to 0 to 5 seconds. Understand? From here to here, it takes 5 seconds. If I ask you, how much is the change in velocity? How you gonna exactly find that? Do let me know in the live chat if you can find this one. So at the same time, we run the class 12th series as well, but in the alternate days. So tomorrow you will be having the class 12th lecture, okay? At the same time, 6 o'clock, okay? Yeah, at 9 o'clock, you will be having chemistry classes lecture for 12th class tomorrow. Exactly. Now see, listen to me. So can we definitely use this use this formula over here in order to find the change in velocity? A is equal to delta V by delta T. Simply, yaar, understand? We have to find the change in velocity. Take it over there. So can we use this? Delta V is nothing but A delta T. What is this? This is change in velocity. This is change in time. From t is equal to 0 to 5 seconds. 5 minus 0, that is 5 seconds. So can I say change in velocity over here? Acceleration is constant. That is 10 multiplied by this 5. It will come out to be 50. Understand? So can I simply say that this formula, by this formula, if acceleration is constant, I can get change in velocity. I can find change in velocity. If acceleration is constant, I can find change in velocity by using this method. Okay. Now I draw the same situation graphically. If acceleration is constant, means the graph of the acceleration time graph will be something like this. At different points, at different times, acceleration is constant. 10, 10, 10, 10, 10. Understand? Yes, yes. It is electrostatics, okay? Now, if I ask you simply over here to tell me the area under this one. So tell me the area under this line. You will simply say area will be nothing but area from 0 to 5. Okay, this is from 0 to 5. Area will be nothing but it will be length multiplied by this breadth, that is 5 into 10. So how much it will be? It will be nothing but 50. So now can we say that, see, area is coming out to be the 50, means area of this acceleration time graph, area of this acceleration time graph, area under this acceleration time graph is coming out to be the same as change in velocity when we draw the same situation in real life. So can I say that from this one, area under acceleration time graph gives us the change in velocity? 100%. So what it is exactly, so this is nothing but change in velocity. Why? Because see, this was the situation. We calculated the change in velocity with the normal formula. Afterwards, what we exactly did is that we plotted the same situation graphically. Okay, we plotted the same situation graphically, and we found out that the area under this line is coming out to be the same as change in velocity over here. So can we say that this 50 area under acceleration time graph gives us the change in velocity? Fine. Come on, let's move on to the next one. Now, in case of a curved graph, what does area under the curve mean? What does area under the acceleration time graph means? Yes, definitely this is sufficient for JEE, bro. This is JEE English Unacademy, obviously. So you'll not get this much of information in any of the lectures. Go watch it. Check it over there also. At the end, I'll be showing you the previous year IIT JEE problems as well. Don't worry about that. Without watching the lectures, you are judging, is this sufficient for JEE? Come on, man. Chalo, let's have a look over here. If I say the graph is, for example, something like this. Now the point over here is, if I say acceleration is not constant, in that case, how you are supposed to find the change in velocity? That is the task, okay? Like previously we have discussed. See, in this case, previously we used the normal formula in order to find the change in velocity. We got 50. And over here, we got the area under this acceleration time graph by using the normal formula, because this was a straight line, length into breadth. Now the point over here is, if acceleration is not constant, in that case, how you are supposed to find the change in velocity? This is a difficult task. And if the graph of that is coming out to be like this is a curved graph. In case of this curved graph, how you are supposed to find the area under this curved graph? In case of straight line, it is easy, but in case of curved graph, it is a bit difficult. That is what is our task. In case of a curved graph, how we are supposed to basically find the area under the curve and this find the change in velocity in this case also. Now, if I say, for example, from this point to this point, acceleration is changing. But what if I tell you to do one thing, keep on reducing this time interval, this a delta t time interval, you find a very, very, very small point. Understand? At this point, how much will be the time interval? You will say simply that is nothing but dt. Very, very, very small time interval. Fine. At this very small time interval, how much will be the acceleration? See, from this point to this point, acceleration is changing. But at this very small time interval, can we say acceleration is nothing but that will be constant? 100%. For very small interval, it is nothing but constant now. So acceleration is constant. Now, can you tell me how much is the change in velocity? We can use the formula. Understand? So what is that? Velocity into time. Understand? That will give acceleration into time, give us velocity. The same formula. That is nothing but, see, if I say a into dt, how much it will be? It will give me change in velocity at this point of time. How much that will be? That will be very small. Like in previous case, from this point to this point, change in velocity is delta v. Understand? At this point, if I talk about change in velocity will be for very small interval of time, very small. So can I say that will be nothing but dv. So how much that will be? Dv is nothing but a dt, because we say acceleration is nothing but dv by dt. Understand? So dv is a dt. Similarly, we'll find the acceleration here, acceleration here. Sorry, velocity. And we will integrate all of these. Now integrate this velocity, it will be nothing but integration of a dt. When we integrate this velocity from this point to this point, we'll find the change in velocity from a point to b point in general. That is what was our goal exactly. This is the English channel, bro. I'm not supposed to talk in Hindi, that's why. Okay, Ankit. So So this is basically dv. Can we say this is nothing but delta v, integration of dv, small change in velocity. When we integrate, we'll get the large change in velocity over there. So can we say this is nothing but integration of a dt? I hope everybody is able to understand this. Now, same is the case over here. How to find the, we know area under the acceleration time graph gives us change in velocity. Now over here, in this case, how we are supposed to find exactly the change in, how we are supposed to find the area. So for that, we have to divide this in infinite number of small rectangles. Understand? Small, infinite number of rectangles. Understand? Now, find the area of this one. If I say from here to here, time is a dt, delta t. At this point, how much this will be? This is nothing but it will be dt, very small time interval or very small width over here. But at this point of time, it will be nothing but acceleration is a. Understand? Constant for this one. So width is this one, width is this one, height is this one, acceleration a. Now you can find the area of this one. That will be nothing but very small area. That is what we call the dA. It is nothing but how much? Length into this breadth. That is a is the length, and breadth is basically dt. Understand? Everybody is able to understand this one. Now, similarly, we can find the area of this rectangle. Understand? Because we have divided this in infinite number of rectangles. Now, integrate this from this point, from T1 to T2 exactly. So, can we basically integrate this one? Like over here, we have to integrate this from this point to this point. Same is the case over here. So, we know area under the acceleration time graph gives us nothing but that gives us change in velocity. Over here, if this is a small area, so it will give us the small change in velocity. So can we definitely say that it is nothing but integration? If we want to find the total area, that is integration of dA, it will give us the total area. So integration of a dt. Understand? So it is nothing but integration of dv. So we can clearly say that delta v over here, because integration of dv is nothing but delta v, small change in velocity. When we integrate it, we will get large change in velocity. It is nothing but a dt exactly. See, this is how we exactly got the change in velocity. This is how we exactly got the change in velocity. That's why we say, if acceleration is given, you are supposed to find the velocity, do the integration. And if velocity is given, you are supposed to find the acceleration, do the differentiation. Fine. Now let's move on to the next one. Now we have some questions. Let's get done with the questions and we are done with the lecture. Okay. Everybody till here understood everything? Come on. Okay. Okay, ladies and gentlemen. Come on. I want everybody of you, this is acceleration and this is time over here. I want everybody of you to tell me in this case, how much is basically the jerk. Okay. Can you tell me how much is jerk? How do we exactly find the jerk? That is rate of change of acceleration. That is slope. Understand? Because slope of acceleration time graph gives us the jerk. Now in this case, can we say acceleration is basically constant? Acceleration is constant, 5 meters per second square. Understand? If acceleration is constant, means change in acceleration will be what? That is 0. Or simply slope of this one will be nothing but, can we say slope is what? Tan of theta. How much theta is making over here? 0 degree. This line is parallel to this one. Tan 0 is 0. So in this case, slope is 0. So we know dA by dt is slope in this case. That is nothing but jerk and that is nothing but 0. So in this case, jerk is 0. Hey, how will be the jerk? 5, man. Okay. Now let's move on to this one. Can we say this is acceleration and this is time over here? In this case, could you please tell me what will be exactly, if I say this is making the theta, what will be exactly the slope? You will say, sir, slope in this case is nothing but that is tan of theta. So that is nothing but between any 2 points, or every point, that will be same over here. Understand? You can say dA by dt or ds by dt, whatever it is. Okay. dA by dt, if I say that is nothing but jerk. Understand? Over here. So how much that will be? Here jerk will have some value. Understand? And in this case, can we say basically in this case slope is positive? Why? Because slope jerk is positive. Why? Because in this case slope is positive. Slope is positive. Why? Because theta in this case is less than 90 degrees. When theta is less than 90 degrees, in that case, slope is basically positive. Okay? Yes, we can say. So jerk in this case is positive, jerk in this case is, and jerk in this case is constant. Because slope in this case is constant. At every point, it is making the same angle, theta, theta, theta. Praveen, you able to understand this one? This is acceleration. This is time. This is acceleration. This is time. Okay? I just want to know about these two graphs. Can I say in this graph exactly slope will be what? Slope will be negative. Why slope will be negative? In this case, I'll just write it over here. Slope is basically negative. Why? Because in this case, theta is greater than 90 degrees and less than 180 degrees. In that case, slope is basically taken as negative. This is strictly decreasing. Yeah, if slope is negative, in this case, means the dA by dt is basically slope. So what is dA by dt? That is jerk. If jerk slope is negative, means jerk in this case is negative. Understand? And this is basically a straight line. This is a straight line, means at every point slope will be constant. So can we say slope in this case will be basically constant? Slope is constant, slope is negative. Understand? Means jerk is constant. And acceleration in this case is positive, and finally becomes zero. It keeps on reducing. Now in this case, can I say acceleration is basically negative initially? This is negative acceleration. From the upper side, acceleration is positive. But in this case, slope is what? Slope is what? Slope is positive. Why? Because theta in this case is less than 90 degrees. See how much this angle is. This is less than 90 degrees. If we say over here, theta is less than 90 degrees. In that case, tan theta is positive, means slope is positive. Yes. So in this case, okay. So in this case, can we say jerk is basically positive? Jerk is positive. If jerk is positive, means slope is positive. And in this case, it is basically constant. So we say jerk is constant. So in this case, we say acceleration is acceleration changing uniformly, and in this case, slope is constant. Okay? Everybody? Now, JEE Mains 2019. I want everybody of you to focus on this question and do let me know what is exactly the answer of this question. Come on. Can you guys solve it? Solve it as soon as possible if you can do it. Okay? Which of the three graphs represent the same motion? Same motion. Understand? This graph, this is acceleration time graph, velocity time graph. This is displacement time graph, and this is a displacement time graph. Okay? Which of the three graphs? I'll just give you the option. That is option number 1. Come on. I'll just give you the options over here. Option number 1 is A, B, C. Option number 2 is, that is A, B, D. Option number 3 is, this was asked in JEE Mains 2019. B, C, D. And what option exactly? Okay, let me just give you these curves exactly. This is something like this, and make it something like this. Fourth option will be something like A, C, B. Come on. Can you just option number A, option number B, option first, second, third, fourth. Which option is correct over here? Okay, come on, tell me over here. Exactly. You just need to solve this. Option B. These are the options. This is the question. This is a graph. You have to tell me which of the three graphs among this represent the same motion. This, or this, or this. What? Options are here. First option, second, third, fourth. Understand? Tell me. Option 1, option 2, option 3, option 4. Exactly. Tell me. A, B, D. Praveen is saying option 2. That is A, B, D. How can you tell me, Praveen? How? What is the logic? Come on. Praveen, what is the logic? Now see, let me just tell you why. See, in this first case, can we say clearly acceleration is in this case that is constant? Okay. See, at this point, acceleration is, for example, 10 meter per second square. If I say, for example, 10, 15, whatever it is, at this time, acceleration is same. Acceleration is not changing. Acceleration is constant. Okay, fine. This is the first graph. In the second graph, this is a straight line. Okay. Can you tell me the slope of this graph? That is velocity time graph. Slope of this velocity time graph will be constant. Why? Because at every point theta is same and the velocity is changing uniformly. In this case, if slope is constant, means acceleration is constant. Okay, means if acceleration is constant, because slope in this case is constant. Fine. And in this case, clearly we can say acceleration is positive. Acceleration is positive from the upper side. In this case also, slope is constant as well as slope in this case is positive. Why? Because theta is making less than 90 degrees. That means in that case, slope is positive. Acceleration constant, slope positive. Fine. Let's move on to the graph number 3. Let's move on to the graph number 3. This graph is basically, it is nothing but s is equal to t square. Okay. This curve is having equation as s is equal to t square. Now, if I ask you to differentiate this one, what will you do? You will say ds by dt. It will come out to be nothing but 2t. Differentiation of this one. What is that? Differentiation of ds by dt is nothing but velocity. Means velocity is 2t. Again, differentiate is, that is dv by dt. How much is that coming? The differentiation of this, that will come out to be 2. So means 2 is what? Constant. If 2 is constant and this is positive, means in this case, so this is acceleration. Acceleration is coming out to be constant. Acceleration is coming out to be positive. Or you can check it with the other method also that I have showed you previously. At t is equal to 1, this is 1. At t is equal to 1, s is 1. At t is equal to, then you check the change in velocity, change in acceleration. That's a bit longer method. This is the simple one, short trick. Now see, this case completely resembles. Now let's talk about the option 4. Let's check option 4 before marking it. Now, this option number C, initially we can clearly say that there is some speed, okay, because this is having some slope. This ds by dt has some value. If we draw tangent over here, this will have some velocity over here, whatever you say, okay. And finally over here, slope, speed, velocity, ds by dt is becoming 0 because slope is 0. Because this is a straight line parallel to this line. So if slope is 0, means then afterwards velocity is becoming 0. So there is no chance in this acceleration can be basically constant positive. So this cannot be the option. So we have A, B and D. So A, B and D, option number, this is the correct answer. Okay. Option number 2 is the correct answer. Please start maths in the channel. Okay, we'll start. Don't worry about that. Now, this is the question. It was asked in IIT JEE 2004. Come on, I want you people to answer this one. Hey, everybody got this one? Previous question. You got the feel of previous question. Come on. I need to know if you got the feel of previous question. Okay. Now, a car starts from rest. Find the maximum velocity. Find the maximum velocity attained. It is starting from, there is a car which starts from rest. Its graph is coming out to be like this. Acceleration time graph is coming out to be like this. We have to find its maximum velocity, how much maximum velocity it has attained in 11 seconds. Okay, that's what we are supposed to find. Now, we have to find velocity. Understand? Acceleration is given, acceleration time graph is given. If you are supposed to find velocity from acceleration or acceleration time graph, whatever it is, means you have to do some integration stuff, okay? Or you have to find some area of that graph, because that will give you the velocity, only change in velocity. So means we have to do the reverse process. This I have told you before also. Now, if we find the area of this area under this acceleration time graph, this will give us clearly change in velocity. So let's find the change in velocity first. Afterwards, we can definitely find this. What is the maximum velocity? Can you tell me option A, B, C, D? A, sir, no, man. Okay, come on. If I say, for example, area of this one, how can we find the area of this triangle? Can we say that is nothing but, see, change in velocity, because this area will give us change in velocity from this point to this point, 0 to 11 seconds, previously explained only. Okay, so how much will be the area over here? 1 by 2, that will be nothing but 10 multiplied by this 11, so 2, 5. It will be nothing but, how much exactly? It will be nothing but 55. Okay, this is, so change in velocity is 55. Now the question itself says that car starts from rest, means initially at t is equal to 0, if we say initial velocity u is 0, understand, it starts from rest. So what is this change in velocity? This is nothing but v minus u, understand, is nothing but this 55. So it says that how much is u? That is initial velocity. Can we put 0 over here, because initially velocity is 0, so it will come out to be 55 meter per second. Okay, so which option? Option D is correct. Yeah, exactly, option D is correct. Fine, that's why I told you, either fine. Now if we had an equation of acceleration time graph over here, acceleration versus time, in that case we'll have to use the integration, understand that integration. See, you have done integration. For that, there should be some equation over here. Understand? If we have that equation, we'll use. But we are given the acceleration time graph. That's why I told you to find the area. If a acceleration time relation is given and we are supposed to find the velocity, in that case, we'll do the integration. Method is same. Just you have to understand what is given. Then accordingly, you have to approach the problem. Understood, man? Come on, IIT JEE 2005. Its corresponding acceleration time graph. This is the velocity. This has to be x over here. Okay, this is x. This is not time. Okay, this is given. Velocity versus position graph is given. You are supposed to find its acceleration time graph. Come on. Can you do it? I'm fine. Yeah. Yala mala. Yala mala, I'm fine. Okay, now let me just solve this one. Let me just solve this one. See how we can exactly solve this. Its corresponding acceleration time graph. Okay. This has to be the acceleration. Yaar, kya likha hai isne? Acceleration. Okay. Its corresponding acceleration time graph. Now. Okay. Fine. Now. Listen to me very carefully. If we try to have a look on this graph, can you tell me what is the slope of this line? Slope of this line will be what? That is nothing but dv by dt. Sorry, dv by dx, because it is velocity versus x. So I can definitely write it dv by dx. What will be that? That will be clearly negative. Why negative? Because theta is greater than 90 degrees. See, this theta is greater than 90 degrees and less than 180 degrees. Okay, less than 180 degrees. So theta is greater than 90 degrees, less than 180 degrees. In that case, slope is negative. So slope of this line is nothing but dv by dx. That is negative. Clear? Now, can you tell me, see, here velocity in terms of position. Can you tell me the relation of acceleration, which is in terms of position? You might have studied this. If we write acceleration as, that is nothing but dv by dt, rate of change of velocity with time. Now do one thing, multiply dx from here, divide dx from here. Dx by dx, it will cancel off. It will again be dv by dt. So now do one thing, interchange. Take this dt over here, take this dx over here. We can do that. So this is nothing but, this will be dv by this dx, and multiplied by this will be dx upon this dt. Now what is dx upon dt? Rate of change of displacement with time. This is nothing but velocity. So we can write acceleration is nothing but v dv by dx clearly. V dv by dx. Now the point, yeah, exactly. So v dv by dx. Now you tell me one thing, what is dv by dx in case of this line? Clearly that is negative. So can I basically write acceleration is nothing but v of negative, because this is negative. So whatever the acceleration comes, whatever the velocity of the value we'll put over here, ultimately acceleration is coming out to be negative, because this is negative. So acceleration will be what? Nothing but that will be negative. Now you will say, sir, if the velocity is also negative over here, velocity is positive, understand? This is from the upper side. So velocity has to be positive, positive, negative, that will come out to be negative. So ultimately, acceleration will be negative. So this is the first clue. tell me in these graphs, in which acceleration is negative? Clearly in this acceleration is not negative, understand? So in this graph acceleration is negative, in this graph acceleration is negative initially, in this graph acceleration is negative. Okay, now let's find the second clue. This was the first clue. Understand what we exactly did? We found the slope of this one, that is negative. Accordingly, we got the acceleration as negative. Okay, I showed you the proof also. Now the second clue is basically, see, velocity keeps on reducing, means at this point, after some distance, when car has traveled some distance, see, x naught, from 0 to x naught. So at this point, clearly it says that at x naught this velocity decreases. Here means here velocity becomes 0. If velocity becomes 0, means acceleration will also be 0. Understand? Acceleration will be also 0. In this case, afterwards, is acceleration 0? No, it remains constant. Cancel. In this case, is acceleration 0? No, it remains constant. Cancel. Okay, everybody understood this one. Now, which case is over there? Here, acceleration becomes 0 after some time. Initially, it was like this, and slope was constant also. Slope was constant also. Slope was constant also. Exactly. Fine. So we can definitely take this one. We can definitely take this one. Okay. Hey, half C, man. Acceleration has to be 0 afterwards. That's why. Praveen. Come on. It's okay, buddy. It's okay, buddy. Okay. People are missing today. These were the previous year questions from this one. You are asking me to give the tough questions. From where am I supposed to get the tough questions if we are studying the acceleration time graph itself? And these are having still, these are having the good level, okay? And you are right now in acceleration time graph itself. So the questions that have asked previously, I'm showing you that. Sir, please tell differentiation and integration like you said in Fury series. Yes, I'll complete differentiation and integration also in this series, okay? Don't worry about that. That's very nice being artist. This is JEE channel, okay? But the neat people can also join this one. Neat people can definitely join this one because we start from the basics itself. Now, you can definitely... okay. Now tell me what is the average acceleration from 0 to 20 seconds. Can you tell me? Okay. Everybody, tell me what is the average acceleration from 0 to 20 seconds. Everybody of you, can you solo it? Can you solo it? Can you solo it? Thank you. That's nice. Everybody of you, I want everybody of you to solo this one. Sir, can we use Ampere's circuital law to find the magnetic field at the center of coil? So, is this your question? Ampere's circuital law. कौन सा था? ये B dot dl is equal to mu times of I. This one. And being artist, is it you are asking me this? This is some sort of circular coil or something like that, okay? Okay, circular loop, circular coil, and in between, at the center. Now see. In case of this Ampere's law, yeah, exactly, okay, fine. See, have you studied this Ampere's law exactly, what this exactly is? Sorry guys, this is a bit off the topic this guy is asking me right now over here. Okay, whatever it is, I'll just tell you the answer. Whatever the loop it is, I'll just tell you the general answer. After that, you can use it on anything. See, this B dot dl is, what is this? This is basically the line integral. Do you know what is line integral exactly? Line integral means exactly, if for example, this is the a line, okay? I'm asking you, okay, just a second. This is the last question and we are done with the kinematics. Okay, not a problem. So if I say, I'll just show you over here. Now see, if I say this is integral B dot dl is equal to mu naught times of I. Okay. Now, this is the Ampere's law. We can use this in order to find the magnetic field in, that is, simple geometrical figures. Now here you are asking me to find the what do we say, this magnetic field at this point, that is the point at center exactly. Okay, so this is definitely not the simple geometrical figure, so definitely we cannot use this. I'll tell you why we cannot exactly use this. So this is basically B dot dl. That means we can find the magnetic field along the line integral. Magnetic field with line integral. What is that? Line integral means this is the integral, means a line integral. Understand? Along a line. If for example this is a line of length L, if I say over here how much is this, you will say this element is nothing but dl. If I say you integrate this, this will be line integral. Integration of this dl will be complete full L. It will give us full L. Now what I am trying to say over here is, if I ask you, you are asking me this question. Okay, if I ask you, for example, if I give you the example, this is the common example that you can find in any book. Okay, you can find in any book in this case. Now see, listen to me. If you find this in any book, so if we say, for example, this is a conductor which is having the current I, and the current carrying conductor, it will create the magnetic field over here. At this point, if we try to find out the magnetic field, see, this is, for example, at our radius. Okay, at any this is the circular ring over here at this point. So can we say what is the length of this field? This will be dl. Okay, at this length, how much will be the magnetic field? That will be very small, so we can take basically it a constant. Now, whatever it is, I'll just tell you the simple approach why it is not why cannot we find this one. Rest you do the calculations at your home, man. Okay, so in that case, clearly we can see at this point magnetic field will be constant. Now if you integrate this one, in this case, how much will be the magnetic field? So that will be nothing but B multiplied by, if this is R, that will be 2 pi R is mu naught times of I. So B will come out to be mu naught times of I. I guess this is correct. 2 pi R. Okay, so you got the magnetic field of this whole wire. Okay, exactly, whole circular ring. Now in this case, you are asking me if this is a loop or this is a circular ring, whatever it is, whatever you are saying that. Okay, whatever you are basically saying that. So in that case, the current I is, you are asking me to tell me the magnetic field over here. You have to take this, we can use on the magnetic field along with line integral. So this is the point. This is not the simple geometrical figure. What you gonna take the dl over here? So definitely we cannot basically use this one in this case. Okay, so this, and over here we say this is closed integral. Understand? Closed magnetic, closed loop. This gives us the information. This is a closed loop. Over here, how can we create that closed loop? Like this one. This is having the closed loop conductor in between. So this is, that's why we are basically, we cannot find this one. Now if you ask me, sir, how can we exactly find the magnetic field at any center? Use the Biot-Savart's law. That will give you. Now let's move on to basically our topic. Come on, let's move on to the topic right now. So what I'm asking you to find the average velocity from 0 to 20 seconds. From this point to this point, I'm asking you, yeah, find this point to this point. I'm asking you to find this one. Okay, that's nice. 300. Oh, kahan se 300, man? How to find the average velocity? What we are supposed to, sorry, average acceleration. This is average acceleration, not average velocity. Average acceleration we are supposed to find in this case. How do we exactly find average acceleration? Okay, we say average acceleration is nothing but delta V by delta T. Now here you will say delta V is nothing but V2 minus V1. Yeah, this is not the velocity time graph, man. You will say V2 minus V1. This is not the velocity time graph. Understand? This is acceleration time graph. In case of acceleration time graph, how do you find the change in velocity? You getting me what I'm trying to say? We find the area, because area of acceleration time graph gives us the change in velocity. So area from what? From 0 to 20 seconds means this area from 0 to 20 seconds means a delta V will be over here. That is area of this triangle plus area of this rectangle. How much that will be? 1 by 2 base, that is 10 multiplied by this 20, this 20, and this plus length into breadth, area of this rectangle, that's length is what? That is 10 multiplied by breadth is what? That is 20. This is 100 plus this is a 200, it will come out to be 300. Now change in velocity, how much? That is 300. So can we put it over here? 300 upon change in time, 20 minus 0, that is time, because you have to find from 0 to 20. So that is 20 minus 0, that is 20. This will cancel off to 15. So it will come out to be 15 meter per second square. How 300, man? Okay. Okay, everybody. I want everybody of you to join me in my special class. We are supposed to find from 0 to 20 only. We don't have to take this triangle. We don't have to take this triangle. Okay? Because from 0 to 20 only. From 0 to 20 only. Come on. Okay, yes. And now guys, join me on special class. That will be at 8 o'clock. Okay, everybody. 8 o'clock, 8 o'clock. Okay. And I want everybody of you basically, see, people till now were saying that, sir, there is no batch on Unacademy which is completely in English language. So I suggest you to basically join this batch. This is the Spark batch, which recently Unacademy has launched. This is for 11th and JEE 2023 if you're appearing for. Okay. Now, this starts from 18th of August, means it started from tomorrow, it's today itself, understand? So basically these are the educators which are the top educators from different states, different states. You can definitely enroll in this batch in order to boost your rank, okay? Fine. Now, this is the Shine batch. I suggest you the people who are appearing for Advanced 2022 or wanna basically increase their. Okay, so this Shine batch you can join in order to boost your rank in your JEE Advanced 2020. This has already started on 11th of August. You can definitely go for this one. These are some of the top educators from different states. And if you check this plus subscription, on Unacademy, there are countries' top educators which basically teach you over there. You will get different number of benefits. So if you take this plus subscription, you will get live classes, weekly tests, structured courses, unlimited access. Means you can watch anybody's lecture, and every week you will be having the test over there. And the next thing, in Iconic subscription, you will be getting all of the you will be getting all of these benefits that you get in plus. And there are some extra benefits also in Iconic. That's the personal guidance, test analysis, experts guidelines, study material, study planners. These are so many benefits. You're gonna get it nowhere. Okay. Okay, thank you. And you can definitely follow me on Unacademy. This is my username. You can definitely check me out there. And this is IIT JEE subscription. If you take it for 12 months, 18 months, 24 months, you will definitely get the branded notes that will be delivered to your doorstep. Okay. And if you take this plus subscription for 12 months and 24 months, you will be getting 2 months of extension. So I suggest you to grab it right now. And most importantly, you can take this subscription plus subscription for 3 months, 6 months, 12 months, 18 months, 24 months. Okay. These are the prices mentioned over here for the respective months. But if you want the maximum possible discount, you can definitely go for this one. You can definitely go for this one. And this is the maximum possible discount. If you use this code, you can definitely get the maximum possible discount. So in order to go for Iconic subscription for 12 months, for 18 months, for 24 months, you can definitely use this code in order to get the maximum possible discount. I suggest you to take the Iconic subscription because this is having so many benefits. Okay. Now, exactly. And this is the IIT JEE Mega Combat. And in this one, there is a 4 crore plus scholarship that you can get if you go for this one. This will be on 22 of August. This will be a test of 21 questions in 60 minutes at 11 a.m. You can use Yawar code in order to enroll this one. At least go for this one. Okay. Okay. At least go for this one. Now, This is the Unacademy Mega Combat. You can definitely go for this one. Fine. And if you find any of my content as inappropriate, there is a link in the description. You can definitely report over there. Thank you so much. At the end, I want you people to like this video before you leave and subscribe to this channel, JEE English Unacademy. Hit the bell notification because this will give you the update whenever we come live. And like this video, share this video. Thank you so much. Take care. Bye-bye. I need to leave right now. Thank you.